guys. Okay, I promised you a quick video on the normal curve and reading table A. So I'm going to just kind of go through some quick examples, and I drew you a picture here because you know I'm an artist. So we have the normal curve, which we harped on. So I'm not going to talk too much about when the questions are specifically about 68, 95, or 99.7% of the data, right? So we go to table A. We standardize the data so that the mean is 0 and each standard deviation is 1 to the left or 1 to the right. Positive if it's to the right, negative if it's to the left. And then we standardize the data using the z-score formula where we took the data value, subtract the mean, and divide by standard deviation. Okay? So I'm going to give you some really generic problems. It says if you have data where the mean is 12 and the standard deviation is 2, what is the percentage of the data that is less than 13? So this is the easiest kind of z-score problem, okay? Less than. Yay, that's exactly how table A works. And then also we're just looking for a percentage, so it's really just direct work, okay? So the first thing we do in a problem like this is we find a z-score. So we take 13, subtract the mean, which is 12, and divide by standard deviation, and we end up with 1/2, which when you draw a picture of this scenario, so I'm going to get on this side. When you draw a picture of this scenario, it's really obvious, right? So here's my mean of 12. I counted off 2 standard deviations, and I find 13. I shade to the left, and I say, man, 13 isn't even on here. But it is halfway between 12 and 14, so it's going to be half a standard deviation. But even that's, we can get from this, but we can also get that from that z-score formula, okay? Then you're going to go to table A. Table A, and I'll put it up in just a second so you can kind of glance at this if you don't remember. If we go to where z is 0.50, right, that's the same thing as 1/2, the decimal that it gives us back is 6.6915, which means this, 69.15% of whatever this data happens to be about will be less than the 13. Okay, hold tight for a little switch up. Okay, just a little bit harder. So let's say the question says something along the lines of, find the percentage of data more than 3 if you find you have a mean of 7 and a standard deviation of 1.5, right? So now here's the problem. You're like, oh, I did that. I can do that. I did that just a second ago. So you say, oops, you make a picture, ignore the blue stuff for just a second, and you find where 3 is, and it's still not on a perfect standard deviation. And because of that, you go to z-scores, and you do 3 minus 7 divided by 1.5 to get negative 2.67. And then you go to table A to get that decimal, and the decimal tells you 0.0038. So you're like, yeah, 0.38%, got it. And then you compare it to your picture. You don't got it, right? Because there's no way that all this red stuff we shaded for things that are more than 3 are really only 0.38% of the curve. Oh, so what we really need is the other side of the curve. So you have 2 options here. You can do it with percentages. You can say, well, that's 100% minus 0.38% for 99.62%, or you can do it with 1. So you can say that's 1 minus 0.0038, which is 0.9962, then turn it into your percent, right? So this means 0.99.62, not 0.99, 99.62% of all the data in this data collection should be more than 3, okay? And the difference here between the last problem and this problem, and I didn't circle this, I'm feeling regrets, so much regrets that I'm going to add it, okay, is more than, okay? So when you see more than, you have to remember that table A is going to collect area from left to right, okay? From left to right. So be really, really careful with how you're pulling the data and the way the question is worded. Less than, yay, easy. More than, one more step, okay? Hang on. Next type of problem you might see is a between problem. So you could see something like this. Hold on. Example 3. Not very clean when I'm writing and holding. All right. Find the percentage of data between 5 and 8 if the mean of the data is 6 and the standard deviation is 2. So start with a picture, right? Here's your normal curve. Mean is 6, standard deviation is 2. Between 5 and 8 looks like this, right? Start with a picture. Once you have your picture, here's the thought. The thought is table A will give me the percentage less than 8, and table A will give me the percentage less than 5. What it won't do is magically give me what's between 5 and 8. But what I can do is take all of 8 and take off 5, and that leaves me with between 8 and 5, okay? So here's what you do. You find the percentage for less than 8. So that will be 8 minus 6 divided by 2, or 1. Let me fix this little computation error. Oh, there's no computation error. I'm feeling okay about it. Okay, I changed my mind. Okay, so 8 minus 6 is 2, and 2 divided by 2 is 1. No longer feeling bad about it. All right, go to Table A, and Table A tells you that one standard deviation above the mean is 84.13% of the data. Then do the same thing for less than 5. So your z-score is 5 minus 6 over 2, which is negative 1/2, which Table A tells you 30.8% of the data will be less than that. Then switch to between 5 and 8, which is to take that 0.8413, subtract 0.3085, and end up with 0.5328, telling me that 53.28% of the data will be between 5 and 8. So that's a less than, and a greater than, and a between. So now let's switch it up in just a second and look at what happens when you're looking at a percentage for a data point. Next kind of question says something like this. Again, these are all really generic. Given a data set, or given a set of data that has a mean of 10 and a standard deviation of 3, 27% of the data will will be less than what value? Less than what value? Okay? So we draw ourselves a picture. It looks something like this. Standard curve, mean of 10, standard deviation of 3. Okay? And then we start thinking to ourselves, 27%, where would that be? So if I come over here to 3 standard deviations away, that would be 15 or 0.15%, right? Then come a little bit in, add, and you get 2.5%. Come a little further in, add, and you get 16%. And you're not quite there yet, right? At 1 standard deviation to the left, you only have 16% of the data. To the mean, though, is 50% of the data. So that tells you that you would expect your data point to fall somewhere between 7 and 10. Now, guys, I'm talking about how do you start kind of getting some concept of what the number should look like, right? Okay, so come over here and we say, I know this formula is z equals, and then I can plug in mean and standard deviation, right? So z equals x minus 10 over 3. But how do I get a z value if I want to solve for my x value? And the answer is all the percentages are inside, right? So all you have to do is look inside the chart to find the value closest to that 27%, right? So you're going to the table, inside the table to look for that 27%, and you're getting negative 0.59. Now look at my picture. Aren't I almost halfway between 1 standard deviation and the mean? To the left, making it negative. So this z value makes sense to me, right? If I take my picture and just confirm that this makes sense, I'm happy with it, right? And then a little algebra to solve. So multiply by 3, add 10, and you end up with 8.23, which again, go look, is 8.23 between 7 and 10? Yes. So that makes me happy. It makes me feel confident that I probably have the right thing. So that is 27% of the data will be less than 8.23. Okay, I hope this helps. We're not going to do one more, but if I did one more, it would look something like this. Blah, 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 mean standard deviation. Blah, 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 27% of the data, more than what value? More than what value, okay? And then I would need to subtract because I wouldn't really be looking for 27%. I'd be looking for the other side of 27%, which is 73%, right? So I would do my z-score based on the 73% instead of the other way around. Is that right? Am I happy with that? Something along those lines. I'm feeling not confident about what I just said. let me work a problem. Still feeling confident about what I said then. So here's the difference. Given a set of data that has a mean of 5 and a standard deviation of 2, 86% of the data will be more than what value? So here's the problem. In this, if we go about thinking about it in the same way and we go 86% up, then we're here, right, between 7 and 9. But look at the picture. 86% of the data is definitely not more than this. So what we really need to think about it is like this. And I just realized that I did 84% and not 86%. So you'll have to ignore my computational errors here, right? So what I did is I said, if we've got 84% this way, that means we have 16% this way. So really what we need to do is take our 100%, subtract 84, and that gives us 16%. Now, if I start thinking about the normal curve, and what that means is, if I'm taking cumulative frequency, 0.15 plus 2.35 plus 13.5, I actually hit 16 at 3, okay? So actually I could stop here and just say, hey, got to be bigger than 3, although this should have been 86%, so that wouldn't have happened. But I wanted to go ahead and show you, Table A is not perfect, okay? And because it doesn't have exact percentages on it. So here's what happens. We find a z-score for 16, or 0.16, and we end up with negative 0.99, okay, which is, basically negative 1, which you see here. And we run the computation with negative 0.99, and we end up with an x value of 3.02 instead of 3, right? So we got 86, actually 84, because I wrote the problem for 84%. Of the data will be more than 3.02. Okay, so I hope that's helpful, and I'll see you tomorrow for the exam.